Okay, we will move on to the next problem. Find the surface generated by the revolution of an arc of the catenary y is equal to c cos hx by c about the axis of x or x-axis. Okay, this is also a Cartesian equation only. When it is Cartesian equation, what is the formula? We already know the formula. Area of the solid of revolution formula. What is the formula? Area formula. Integral. Here, the limits will be from 0 to x, 2 pi y ds by dx into dx, where ds by dx is equal to under root 1 plus dy by dx whole square. Okay, this is a formula. Why we are applying ds by dx means the equation, the curve is in the form of y is equal to f of x. Okay, y is equal to f of x. That is the reason we are applying this formula. Now, we already know we have to find dy by dx, ds by dx. We have to substitute in that formula. Okay, now we will do that procedure. Given y is equal to c cos hx by c. dy by dx is equal to c sin hx by c into 1 by c. Means sin hx by c. Already this model problem we did in our previous classes also. Now ds by dx, that is under root 1 plus dy by dx whole square under root 1 plus sin hx by c whole square. Okay. Now simplification. Under root 1 plus sin h square x by c. We already know hyperbolic identity cos h square x minus sin h square x is equal to 1. Means 1 plus sin h square x is equal to cos h square x. Cos h square x by c. Square and under root will get cancelled. Cos h x by c will be remained. This is ds by dx. Now we got ds by dx directly substituting in our area formula. Integral 0 to x 2 pi y ds by dx into dx. Okay. Now, what is given by 0 to x 2 pi, y is given as c cos hx by c. Once we will verify in our question, what is y? C cos hx by c. Okay. Into ds by dx is cos hx by c into dx. 2 pi c is constant. 0 to x cos h square x by c into dx. We can't do directly integration for cos h square, sin h square. We have to convert that in terms of cos and sin. Okay. We have one formula. Cos square x is equal to 1 plus cos 2x by 2. This is the formula we have in trigonometry. Okay. Now, we will do same as that formula only. 0 to x 1 plus cos 2x. In place of x, we have x by c by 2. In place of 2, we have 2 by c as constant. Okay. What is a constant here? Here, 2 is a constant, 2 is a constant. Here, in place of constant, we have 1 by c. That is the reason directly in place of 2, we can substitute as 2 by c into dx. Okay. Okay. Afterwards, we have to do integration. Separate that. This will go to numerator, means 2 and 2 also will get cancelled. Pi into c square 0 to x 1 plus cos 2 into x by c into dx. Okay. Pi c square 1 integration is x. Cos integration is sin 2 into x by c by 2 by c by 2 by c 0 to x, 0 to x. And Some simplification also can be done for this. Pi into c square x plus pi c square into sine 2x by c by 2 by c. Okay. Pi c square x plus pi by 2 c cube sine 2x by c. In place of c square, we can substitute c. Why? Because c is a constant. C square, c cube, 100c also we can put c only. This is the area of the surface, given surface. Okay. Uh, Once we can see here the given curve is this, and this is a formula for the given problem. ds by dx, we have the formula. For that, first we find the dy by dx as well as ds by dx substituted in the area formula. Okay, 2 pi into c cos hx by c cos hx by c into dx. This is cos h square x by c. The formula is um, cos h square x, 1 by c is constant. Okay, uh, 1 plus cos 2x, 2x by c by 2 by c. Okay, here 2 and 2 will get cancelled. We are remained with pi into c square. 1 plus cos 2 into x by c. Again, integration individually. 1 integration is x, cos integration is sine, constant is 2 by c here. Okay. After that simplification, substituting upper limit minus lower limit. Upper limit is x and lower limit is 0. Okay, this is the answer. Area of the surface is this for the given problem. And we will move on to the next problem, problem number 3 of areas. Okay. Find the surface of this solid formed by revolving the cardioid r is equal to a into 1 plus cos theta about the initial line. R is equal to a into 1 plus cos theta. Means here the question is given in terms of r and theta. Means what will be our area? Area will be area will be area of this cardioid will be integral 0 to pi, integral 0 to pi, 2 pi by ds by d theta into d theta. Okay, where ds by d theta is equal to under root r square plus dr by d theta whole square. Already in our introduction only, I gave you clarification whether it is the Cartesian equation, polar equation, parametric equation, we have to observe in our question. According to that only we have to apply the formula. Okay, here in place of y, we have y here. What we have to do? Y value is not given. Okay, assuming y is equal to r sin theta. Okay, this is the assumption we have to do in this problem. Y is equal to r sin theta. Okay, before that we will find ds by d theta. Before ds by d theta, we have to find dr by d theta. Okay, given r is equal to a into 1 plus cos theta. What is dr by d theta? A into 0 minus sin theta means minus a sin theta. Now ds by d theta under root r square plus dr by d theta whole square. Okay, r square means a into 1 plus cos theta whole square plus minus a sin theta whole square. A square is completely constant throughout this. 1 plus cos square theta plus 2 cos theta plus sin square theta. Already we did many problems in this model. Okay. A square cos square theta plus sin square theta is 1. 1 plus 1 plus 2 cos theta. Okay. A square 2 plus 2 cos theta. A square 1 plus cos theta. 2a square 1 plus cos theta is 2 cos square theta by 2 formula. Okay. Now, this is 4a squared cos square theta by 2 square and root will be cancelled. We are remained with 2a cos theta by 2. Okay. This is dr by ds by d theta we got as 2a cos theta by 2. Okay. Now we have ds by d theta also. What we have to do? Area, finding area. 0 to pi, 2 pi. What is why we have assumed r sin theta into 2a cos theta by 2 into d theta. Okay, substituting all in the formula 2 pi y. Why we have assumed r sin theta? ds by d theta we got 2a cos theta by 2 into d theta. Okay. Now we have to remove this also. R also we have to remove. Why? Because we have to do integration. R is a variable. R is a variable in terms of theta. We have to remove this. Okay. Now simplification should be done. 0 to pi, 2 pi. R is a into 1 plus cos theta into sin theta 2a cos theta by 2 into d theta. 0 to pi, 2 pi, 2 into 2, 4 pi a square is completely constant. 1 plus cos theta is 2 cos square theta by 2. Sin theta can be written as 2 sin theta by 2 cos theta by 2 and cos theta by 2 into d theta. Means finally 4, 4 to the 8, 8 to the 16. 16 pi a square, 16 pi a square, 0 to pi, 0 to pi, cos power 4 theta by 2 into sin theta by 2 into d theta. Okay, now what we have to do? We can't do integration directly. By substitution method we have to do. Okay, see here. Put cos theta by 2 is equal to t. Cos theta by 2 is equal to t. Differentiating on both sides. Minus sin theta by 2 into 1 by 2 is equal to dt. Means sin theta by 2 is equal to into minus sin theta by 2 1 by 2 into d theta is equal to dt. dt. Okay. Sin theta by 2 is into d theta is equal to minus 2 times of dt. Here in place of this, we will substitute minus 2 into dt. Okay. When we are doing substitution, we have to change our limits also. Okay. Limits we will see here. See, when theta is equal to 0, means cos 0 is equal to t, means t is equal to 1. When theta is equal to pi, means cos pi by 2 is equal to t, implies t is equal to 0. Means completely this will become 16 pi a square 1 to 0, 1 to 0, t power 4, t power 4, this is minus 2 into dt. Okay. Now, minus 32 pi a square. Integration is t power 5 by 5, 1 to 0. T power 5 by 5. Now, upper limit minus lower limit. 0 by 5 minus 1 by 5. Our answer is 32 pi a square by 5. This is our area. Okay, area of the given cardioid. Okay, you can see this problem. You can see this problem. Once again, what we did first, we finded dr by d theta. Okay. After the ds by d theta, after that we have the formula. After formula, substitution, substitution method, changing the limits, we got the final answer. This is the third problem of areas of the surfaces.